Okay, so there's the paper 1. That's the chapters. Grade 11s, work out previous question papers. Please, 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 please. All the question papers you can get your hands on, work them out. Okay, that's how you study for an exam. Paper 2, Analytical Geometry. 33 marks, that's chapter 4. Trigonometry, 27 marks. That's chapter 6. And I'm going to talk to you about, I'm going to show you something there now. Euclidean Geometry, 40 marks. That is why I've been asking you every day, have you done a circle geometry question yet? And then all of you hide your eyes from me. Okay. First thing I want to say about analytical geometry, know your formulas. You must know where there's a plus and where there's a minus. I tried to teach you ways to remember it. The distance formula we get from Pythagoras. Okay? So therefore, it's right-angled side squared plus right-angled side squared. But the reason why we minus inside of the brackets is if I know this coordinate is 4 and the other one is 1, how do you get that length or that part? You say 4 minus 1. So it's x minus x bracket squared plus y minus y bracket squared under a square root. All of it. No? You must know the gradient formula. It's minus minus. Know the midpoint formula. Midpoint is the one with the plus. Plus the 2x's divide by 2. Plus the 2y's divide by 2. Okay. You cannot write a question paper without knowing your formulas. Okay. Then, oh, and with analytical geometry, also know your quadrilateral properties. Know I gave you that nice summary. Ne? Know those things, the inclination angle, all of them. Right, then I quickly want to talk to you about trigonometry. I only have an Afrikaans textbook now, but I just want to show you the sums that I'm referring to. So we did at the beginning at the end of trigonometry. We did this activity, and I spoke to you about this. This is grade 10 work. Okay? So that's where they can give you a coordinate, or they can tell you that 13 cos theta is equal to 12, then you get the function alone. Then you've got a ratio, ne? And cos is adjacent over hypotenuse. So that will mean when you have a triangle, you have to draw the diagram, ne? Then you have the adjacent side and you have the hypotenuse. Then you use Pythagoras to find the third side. Then when you have all three sides, I ask, now what is the sin? What is tan squared plus sin squared? What? You will never calculate the angle without the calculator. Okay, so when this question asks for tan theta, you're not going to calculate theta. But because you have all three sides, tan is opposite over adjacent. So you write the ratio, the length of the side over the length of the side. Do you understand that? All of you? Okay, they can also give you the diagram like this one. Then that m is 2 and negative 1. That means the x is 2 and the y is negative 1. And then you use Pythagoras to find the length of that side. The angle that you are calculating or that you're working with is this big reflex angle. Alright? But do you remember you can't do trigonometry if it's not in a triangle. That's why we get its reference angle. So we get an angle that's between 0 and 90 degrees that will result in the same answers as that big one. Because you remember the graphs, they repeat. You remember that? Okay. So although that is theta, when you use your triangle, your diagram as it is there, you will use that angle right there, that as theta. Do you understand? And when you draw the diagram, remember you draw your line and then it goes to the x-axis. Never to the y-axis, because y-axis is 90 and 270, that's cofunctions. Don't work with that. You draw it to the x-axis. It's the same as, you remember that one where I, for instance, say the tan of 20 degrees is equal to t. Then I ask you for the sin. then you have to go and draw the diagram. So because it's t, you know it's t over 1. Then the third one you calculate with Pythagoras, it's a gogo one, eh? You remember that one? Then it's root of 1 minus t squared or something like that, 1 plus t squared. And then you also just give the ratios because you've got the 3 known sides. Do you all understand that? Okay. So you must learn this as well. It's the first activity, it's a revision activity in chapter, what is it? 6. Okay. Then next in trigonometry we had that the function values where we use 180 minus 180 plus, finding the right quadrant plus or minus because of the cos diagram, and then you give the value in its simplest form. Then we also had cofunctions. Remember, don't play with cofunctions unless you really have to. Okay, where do we have to? Especially when we have a big expression that we have to simplify, and some of the angles are special angles, 30 degrees and 20, and 45 and 60 and those, but then there's a random 27 or 15 or whatever. Then you need to use a cofunction to try to get two that's the same so that they can cancel out. You remember that? Okay. Then the negative angles, remember the sin of a negative is a negative sin. The tan of a negative is a negative tan, but the one with the catch is the cos of a negative is the positive cos of the angle. Because remember I showed you on the graph, on the function, and on the cos diagram. Cos, if you go in the cos diagram, it's positive, negative, negative, positive. If you go in the negative direction, it's positive, negative, negative, positive. So it's exactly the same. That's why the cos of a negative is the positive cos. And once you've done that, you ignore the fact that anything was negative from the beginning. You do the sum as you would have done it normally. Okay. Then we had angles greater than 360. You've got that. This is for, oh, here's that one. I told you, we spoke about that one now. Cos 20 is equal to t. And then they ask you questions. I told you when we did that, I love this question because it tests everything. So no, I love that question. Wink, wink. Then we've got the special angles. You must just be able to recognize the special angles. You must know which of them are special, because then you can cheat with the calculator. Ne? Gives you the answer, you substitute it in the equation. Go and practice that again. Then we've got the identities. Go and practice it again. Remember, I told you guys when it's two fractions, the secret is you get the common denominator. What you did at the bottom, you do at the top. Multiply nicely. Remember, if that's a -1, that -1 will have to multiply into everything, not just into the one. The distributive law, into all the terms inside of the bracket. And then when it's two terms, you take out something in common and so on. And then that exercise 9, it's everything thrown together. The getting it into the simplest form, the reference angles, cofunctions, negative angles, and also then in here we also have the identities. We ask many questions like this as well in the tests. And then it stops there. We haven't done the equations. That's what we're doing the first thing in the third term. We're doing trigonometric equations and the functions. Okay, so not any further than 159. Okay, then at the Euclidean geometry, you must know everything, and I just want to tell you this. The theorem proofs. You remember we did that? The theorem proofs. In the last week of the first term, we did the theorem proofs. And I showed it to you. Now, I'm not going to ask you a full theorem proof, but I'm going to ask you parts of it. So what's important for me is that you guys know, like Theorem 1, né? Where does it come from? We use Pythagoras to prove that thing. That's why it works. Theorem 2, the angle at the center 2 times angle at the circumference. Then we cut it with that construction. You remember that? Then we use the exterior angle being equal to the opposite interior angles, and then because of radii they are equal to each other. That whole thing. Just know where it's coming from. What makes that theorem work? Because I'm going to ask you to complete certain things. Okay. Theorem 3, angle in a semicircle, doesn't have a theorem that you, or a proof that you will have to do. Then angles in the same circle segment, that one, we use angle at the center 2 times angle at the circumference to prove that one, because we put in the dotted lines, then we create the angle at the center, then we say, okay, this angle at the center is 2 times the size of the angle at the circumference, and then it's also 2 times the size of the other one, and therefore we know they are equal to each other. Then we've got opposite angles supplementary. We also use angle at the center for that one. So if I can quickly remind you about that one, you have the cyclic quad, then we put in an angle at the center. Right? We create it, so we cut it, so there will be 2. Now those 2 angles will be 360 degrees. Right? Now if I can say it like this, the one at the bottom of the dotted line will be 2 times the size of the one at the circumference at the top. And the one at the top of the dotted line will be 2 times the angle at the circumference at the bottom. And because these 2 are both twice the size of the ones at the top or at the circumferences, and they are 360, that's how I know the other 2 will be 180. Okay, so they are supplementary. Then the exterior angle equal to the opposite interior angle. That exterior angle and the inside angle, they are angles on a straight line, 180. And then that same angle and the opposite angle is also supplementary because that's the previous theorem. And then the exterior one must be the same as the opposite interior because they both are supplementary to that specific angle. Okay. Then we have the tangent theorems. Radius and tangent perpendicular, there is no proof for that. Then we have the tangents from the same point that are equal. We prove that one with congruency because it's a common line, the radii that are equal to each other, and then the radii that's perpendicular to the tangents. That's a previous theorem. And then we've got 90 degrees side side. So the 2 triangles are congruent, so therefore those 2 lines must be equal to each other. And then the last one, you remember when we did these theorems, I told you we've got bronze and silver and gold and platinum theorems. That last one I told you is platinum. That's the one that I ask a lot, the tangent one. So that's where you prove tan chord. So you would do a construction with a diameter. So that diameter is on the tangent, so there's a 90-degree angle. And because of the diameter, you create an angle in a semicircle. So you've got a 90-degree angle here because of radius and tangent. You've got a 90-degree angle there because of angle in a semicircle. Then with your construction, you cut that 90-degree angle in 2. And you also cut the angle at the tangent, the radius on the perpendicular to the tangent. You also cut that angle in 2. And then one of these angles and one of the other angles, they are equal to each other because they're subtended by the same chord. And then because they are equal, we know that the other 2 will also be equal to each other because the 2 together is 90 and the 2 together is 90. So that's what I need you to know of the theorems, what I said now. Okay. Then you must also know the wording. They asked that questions a lot in the previous papers. So they give you the statement and then you have to complete it. For instance, I asked it in one test as well. I said the angle at the center is, and then you had to complete, twice the size of the angle at the circumference, and then I wanted to mark it wrong for you guys, but I felt sorry for you because it is 2 times the angle at the circumference that is subtended by the same chord. Do you remember that question? Okay. Those things you must complete. An angle in a semicircle is, then I stop there, then you say is 90 degrees. Whatever. So you must know the wording. Okay. The Euclidean geometry is just like the old question papers. First 1 or 2, easy, going, just like find the angle at the circumference, So half of the angle at the center with your reason, what. And then the last 1 or 2 will be the right dash. So that will be in terms of a variable. So you don't have the size as 30, you have it as x. Then you have to find angles that are also x. Or y, then you find angles that are also y. And that's the way we ask you. Okay. Right. Any questions? I see I cut this. I didn't cut this one nicely. Just see if any one of you got this one or a paper like this where the functions was cut off. No? Can you just... Oh, did yours cut off? No. Well, okay. Thank you. There it is. Onthou my. Remind me when we're done marking that we hand it out, okay? Let's just quickly finish marking it. You can take one and send it around if you want. Okay. But that's what I want to say about the question paper. Any other questions? You can take your files. Just don't lose the tests. Bring it back. Okay? Anything else? All right. Can we quickly mark? No, you're not going to talk, no? Okay, the first question was write down the coordinates of C. We spoke about this yesterday. It's -1 and 0. You find that because you have B and then you have the x value of the axis of symmetry. So 3 to 1 is -2 and then 1 minus 2 is going to be -1. That's how you get it. Next one, you had to find the equation of f of x, or the equation of f. So I showed you this trick as well. They gave the standard form as x squared plus bx plus c. So therefore they gave you the value of 1. So you didn't have to put in a value of 1 in there. So you use standard form 3. You substituted in those two x-intercepts and you simplify the equation to be x squared minus 2x minus 3. Right, next up they asked you to find the range of f. The range of f, you take that x value of the turning point, substitute into the equation, you find the y value to be -4, and then the range is -4 to infinity. -4 included, infinity not included. You guys will tell me when there's something that you don't understand. Okay. Calculate the equation of the straight line. So when I look at the straight line, I have B, it's 3 and 0, and I also have A, it's 1 and -4. So you've got two coordinates. You can calculate the gradient, it's 2, and then you can calculate C, it's -6, and your equation is y equal to 2x minus 6. Please be sure that you guys answer the question. If you stop there, you did all of the work, but you will lose a mark, because they said in the form y equal to mx plus c. Do you understand why I took A and B's coordinate? It's on the straight line. Okay. The next question, I just want to use the highlighter to show you guys. Right, first one they asked, where is f of x greater than 0? So that one I'm not going to highlight, that's pretty easy. Here, on the left hand side of the one x-intercept and on the right hand side of the other x-intercept. So it's from -infinity up to -1, it's greater than 0, and from 3 to infinity, it's greater than 0. Do you all understand that? Right. Next up, I'm going to use the highlighter. Okay. So I'm highlighting the parabola where it's positive, and I'm highlighting the straight line where it's positive. I'm highlighting parabola where it's negative, and highlight the straight line where it's negative. So the question asks for greater than 0. Greater than 0 means positive. Positive you get from positive and positive, or negative and negative. So this first part, -infinity, the one is yellow, the one is pink. That's not where I want to be. But from -1, both of them are pink. So it's negative divided by negative. That's where I want it to be. And then after b, both of them are positive. That's also what I want. So if we look at the greater picture, it's going to be from -1 up until infinity. But I showed you yesterday that there is a trick with b. Because at b, both of them are 0. And they are asking for greater than 0. And even if they said greater than or equal to 0, you would still have to exclude b. Because the straight line is also 0. And you are dividing. And when you divide with 0, that's a math error. So therefore, the answer I gave was from -1 to infinity, and then I exclude 3. You can also write it like this, -1 to 3, and then 3 to infinity. Or you can say x is greater than -1, and then you exclude 3. You don't have to write all 3 of them, just one of them. Okay, the last one, they're asking x times the parabola greater than 0. Once again, it's positive, so therefore the x-axis and the parabola must be negative at the same time, or they must be positive at the same time. So when I read it from here, negative infinity, one is yellow, one is red. It's not there. From -1 to 0, yes, there the one or both of them is will be negative, yeah? So that's a part I want. After 0, one is yellow, one is pink. After b, yes, both of them are positive. I'm now referring to the axis and the parabola. So therefore my answer will be from -1 to 0, none included, and from 3 to infinity. Okay, the second last question, that's a level 4. I'm going to explain it to you again. They are asking for what values of p will x squared minus 2x equal to p have non-real roots. Okay, so let me just quickly get your attention for this one. The previous sum that we did that was similar to this, they asked for equal roots. So equal roots means that your turning point is on the x-axis. In other words, your q value is 0. Okay. But they also stated that question, they said f of x equal to k. What will k be? The difference is f of x is the whole equation. So you had to add or subtract to the existing q or c value that was there. Do you hear what I'm saying? Okay. This one is not saying f of x. They are saying x squared minus 2x equal to p. So they actually just asking for a new, if I take p that side, it's the new y-intercept. What must the new y-intercept be for it to have non-real roots? Do you understand that? Okay. Now, for this graph to have non-real roots, this is currently the value of the turning point, and this is currently the value of the y-intercept. So I know that this turning point must become 0. So the graph must move up 4 units. Right? Then it would be equal roots. But that's just the island I want to swim to for now. If that graph, if the turning point is 0 there, it's -4 here, the y-intercept is -3. If the turning point is 0, what will the y-intercept be? -4 and -3, 0 and? Where is it going to cut? At 1. That's not -1, I'm just cutting the y-axis there. So do you agree my C value should be anything greater than 1. If this graph cuts at 1, it will have equal roots. I don't want equal roots. Non-real means they don't exist, and that means it doesn't cut the x-axis. So if this graph cuts any place higher than 1, 1, 1,000000001, it will just lift from the x-axis and there will be no roots. In other words, non-real roots. Do you understand what I need to find? Okay. So in other words, this equation that's currently x squared minus 2x, I want it to be anything greater than plus 1. Not plus 1, greater than plus 1. So the way that they are making this question even more difficult is that p is not on this side. If they said plus p, you would have said p must be greater than 1. Do you agree with me? If the y-intercept is anything greater than 1, it doesn't cut the x-axis. But now they've put the p on the other side. Do you see that's not standard form? Standard form is x squared minus 2x minus p equal to 0. So that now makes this more difficult. Because now I can't say p must be 1. Because if I say 1, then I'm saying it must cut at negative 1. And if it's cutting at negative 1, it will still have 2 x-intercepts. So what must p be at this side if I want that to become plus 1? I can't put in 1, then it will be minus 1. So it must be minus 1. Then it will be plus 1. Does that make sense to you? But now that changes the whole thing. So if p was on this side, I would say x must be greater than 1. But now p is on the other side, so the 1 becomes negative 1. And I'm not using the greater as sign. I have to use the smaller as sign. So if x is smaller than, p. If p is smaller than negative 1, then that means this graph won't cut anymore. Let's test it. A number smaller than negative 1 is negative 2. If I put in negative 2 there, it will go to this side, it will become plus 2. That means your graph is going to cut at 2. If your graph cuts at 2, the turning point will be at 1, and therefore it won't cut the x-axis. So it works. But you have to literally jump into that question to get to it. And every time is different. As I said, the previous one they said f of x. Then you must use the current c value. So if there was a minus 3 there, we have to say you have to add anything more than 4 for that negative 3 to become 1. So you need to consider the question in the context that it's given. Okay. 8.7, they asked for the maximum length of TM. Grade 11s, we've done this many times now. This is T. Yeah. Oh, P smaller than negative 1. Are you done? Okay. This is the point T. This is the point, what was it? No, P. This was P. And this is the point M. Listen to what I'm saying. If you know that P is 10 and you know that M is 2, you know the distance is 10 minus 2, which is 8. But you don't know that. If you knew what the x value is there, you could substitute that x value into the straight line, get the y value, substitute that x value into the parabola, get that value, and then do the subtraction. But you don't have the x value either. Okay. So we won't be calculating the length of PM because we don't know what it is or where it is. The question asks, what is the maximum length that PM can be? Now PM might be here. Then it's very short. Do you agree with that? Then it's going to get longer, 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 longer. Maybe that's the longest. But then do you see that the length is going to decrease again? Okay. What graph do you know that starts small, then it goes and reaches a maximum value, and then it goes back to being small again? Parabola. Okay. So I want to get the equation for the length of this line. Not the distance formula, because I am not calculating the distance. I want the equation or the expression that represents the possible lengths that this PM can have. So what I'm going to do is I take the top graph minus the bottom graph. Always. Sometimes the parabola will be at the top, sometimes the straight line will be at the top. In this case, the straight line is at the top. It's 2x minus 6. So I say 2x minus 6, that's the straight line, minus the parabola. That minus must be multiplied in. Okay. Then when you simplify it, you get a trinomial. Because the length is a parabola, or what do you say, a parabolic value. It starts small, it reaches a maximum, and it goes back to being small again. That's why I am glad I got this. Because this graph has a negative value in front of x squared, that means this, if I were to draw a graph of this expression, it would be a sad parabola. And a sad parabola has a maximum value. And I want to calculate the maximum value. What is the maximum value? It is the y value of the turning point. So once you have that quadratic trinomial, all you need to do is find the q. If you've got q, you've got the maximum value. Now you can do that in two ways. Either you complete the square, I will go through that with you now, or you use negative b over 2a. With negative b over 2a, you will find the x value of the turning point. Substitute into that equation, then you find the y value of the turning point. So therefore, this is the y value of the turning point. That means that the longest that PM can possibly be is 1 unit. It can be less than 1 unit to the left side, and it can be less than 1 unit to the right side. But there's one spot where the length will be the maximum length, and that length will be 1 unit. If you completed the square, you take out a negative of the first two. Then you take half of b, so it's half of 4. Square it, you add it, and you subtract it. Then that negative 4 needs to get out of the bracket. It multiplies with that negative, it becomes plus 4. And then you get that equation in PQ format, in standard form 2. That means that's your Q value. The maximum value of PM is 1. Now they can even take this question further and they can ask you, where is PM a maximum of 1? Where is that spot that PM is the maximum value? And it's very easy. It's the p-value. So at 2, PM at x is equal to 2, PM will be the maximum length of 1. It makes sense that it's not another x, eh? But that wasn't the question. I'm just saying they can ask you that as well. Okay, question 17. We need to hurry. The bell is going to go. Yeah, man. 17 on the Afrikaans kids page. Relax. It's the same one. Write down the coordinates of the y-intercept. Y-intercept means you make x 0, then it's 1. 0 and 1. I just showed the Afrikaans clause here. If you make y 0, it cannot be calculated because you cannot write 0 as 1 over 5. So therefore you know you've got no x-intercept. Just showing you, if you had wondered about that. Next one, the equations of the asymptote. So f's asymptote, that one, it has no q value, but there is a q value. The q value is 0, so it's y equal to 0. The asymptotes of the hyperbola, there is no p value, but it is there. It's 0, so it's x equal to 0. The other one is y equal to 5. Then they're asking which of the functions are decreasing. When the base is a fifth, that's decreasing. Ne? So it's going to be f. The straight line is x over 5. So I told you guys that's the same as a fifth x. That means the gradient is 1 over 5. That's positive. So a positive straight line is increasing. So that one is not. The hyperbola, because of that value 1, I know this hyperbola is in the first and the third quadrant. Ne? So when I read from left to right, do you see this graph is decreasing and decreasing? Okay? So the other one that's decreasing is f. Do you all understand why? Okay? Then you had to draw the graphs. So when I drew the exponential function, I put in the asymptote. I plotted the y-intercept, and then I knew my shapes, so I drew the decreasing. Okay. With the straight line, the y and the x-intercept is 0 and 0. I didn't go and calculate another value. I just drew the straight line because I'm just looking for the shape. It's increasing, but don't let it go up too steep, ne? Because the gradient's a fifth. That means it's a small gradient. So it's rather flat. And then the hyperbola, I put in the two asymptotes. I plotted that x-intercept that I calculated. Ne? And then I joined. I didn't calculate another point. 2.5, they asked about the reflection in the y-axis. You could do it manually, like reflector, and get the answer and see that it's now increasing, and therefore a fifth would become 5. But I think the easiest way is to do it algebraically. Then reflection in y-axis means you put a negative in front of x. That's not standard form. So 1 over 5 to the power of negative x becomes 5 to the power of x. There. Chop. And question 6, they asked for the equation of the straight line if it's up, translated 5 units up. You just add a 5. (2.4) F and H. Okay, any questions? I have one question. Who has done Euclidean Geometry question yet? Dankie, at last.